utility crews, right? Way up high in those bucket trucks.
All the
So
time.
they're doing absolutely crucial work, keeping our lights on, keeping everything running. But it often just goes unseen, doesn't it?
It really does.
And it makes you wonder, how much do we actually know about the safety side, the really intricate, sometimes life-saving measures that keep those operations going?
Well, that's exactly what we're going to unpack today.
Good.
Our mission here is really to pull out the most important bits of knowledge, the key insights from the material we've gathered on bucket truck safety.
Okay.
We're going to focus on the OSHA standards, yeah, but also other critical things, especially for electric utility work.
So like a shortcut for listeners.
Exactly. A shortcut to getting informed about something that's honestly fundamental. Worker safety, grid reliability, it all ties in.
Right. So given how critical it is, where does the safety foundation actually begin? Our source material seems to point straight at OSHA 1910.67.
That's the one. That's the backbone, the foundational standard for these vehicle-mounted, elevating, and rotating work platforms. Bucket trucks, basically.
Gotcha. And the source really emphasizes that following these rules isn't just like a good idea.
No, it's everything. Workforce safety absolutely hinges on compliance here. It's not optional.
Okay, so what are some of those core requirements, like the non-negotiables?
Right. Well, the regulatory FAQ section we looked at highlights a few key things. First off, daily control tests.
Daily.
Every single day. Before use, OSHA Rule 1910.67 C22 says you have to test the lift controls to make sure they're safe. It's basic, but vital.
Makes sense. What else?
Proper stance in the basket. This one's really strict. You've got to stand firmly on the floor. That's 1910.67 C2.
Don't know.
No sitting or climbing on the edge, no using planks or ladders or, anything else inside the bucket to get higher.
Just stand on the floor. Keeps it stable, prevents falls, I guess.
Exactly. And then there's an interesting bit about field-modified lifts.
Modifying the equipment. That sounds risky.
It can be, which is why there are rules. OSHA allows it, technically 1910.67 B2, but only if the modification is certified.
Certified how?
In writing. By the manufacturer or an equivalent entity, like a nationally recognized testing lab.
Okay.
And that certification has to confirm it meets the ANSI A92.2 1969 standard, and that the modified lift is at least as safe as the original.
So rigorous checks. You can't just weld something on.
You definitely not. Safety can't be compromised.
Speaking of things that can get tricky, our source mentioned something people often seem confused about, moving the truck while the boom's up and workers are in the basket.
Yes, that's a big one. The General Rule 1910.67C
Prohibits that.
Generally prohibitive. Okay. But, and this is a key nuance from the source, and the equipment is specifically designed for it. And many companies have actually gotten exemptions from the manufacturers.
Exemptions. For what kind of situations?
Well, typically for short distances. Like the source mentions moving pole to pole for, say, reconductoring or clipping in a new line.
Okay, so specific tasks.
Right. But even then, there are strict conditions. Booms have to be properly cradled. The worker needs to face the direction of travel.
Facing forward.
Yep. And the driver has to go slow, keep a reasonable speed, and constantly scan the area for hazards. It's very controlled.
Which connects directly to another rule, doesn't it? The pre-travel inspection.
Exactly. Rule 1910.67 C2. Before you move the truck for travel, you have to check the booms are cradled and the outriggers are stowed.
With that exception for the short moves we just talked about.
Right. But what's worrying, and the author points this out, is seeing crews, maybe in photos or observations, just not doing it.
Really? Like moving with buckets uncradled?
Yeah, or even with workers still up there when they shouldn't be. Outside those specific exemptions, it's a basic requirement being missed.
That's alarming. It feels like such a fundamental safety check.
It is. And tied into all of this, of course, is fall protection. That's under 1926.502 D16.
Right. Can't forget that.
Absolutely essential. Anyone in a bucket must wear fall protection. And it has to be rigged so if they somehow get ejected.
Which you hope never happens.
Never. But if it did, they can't free fall more than 6 feet, and they can't hit a lower level. It's that critical last line of defense.
Okay, we've covered controls, movement, fall protection. But now, here's where our source says it gets really interesting. This substantial difference between Class A and Class B trucks.
Yes. Class A bare-hand trucks versus Class B gloving distribution trucks. This is a huge distinction and super important to understand.
So what's the core difference? Is it just voltage levels?
It's more about how they handle insulation and the work method. Class A trucks are for working directly on energized transmission voltage, barehanding.
Okay, high voltage, direct contact, how's that safe?
Well, multiple layers. OSHA requires grounding the vehicle best available ground, but crucially, the boom itself is the primary insulating barrier between the worker and the grounded truck.
The boom provides the insulation.
Right. And because of that, there are strict testing rules. A leakage test is required before use.
Leakage test, what's that involve?
They intentionally make contact between the bucket and the energized line for like 5 to 8 minutes and measure any current leakage, make sure the boom's insulation is intact.
Wow. And test.
It has to be. Plus, the booms need dielectric testing at least annually, according to ANSI A92.2. And any hydraulic tool circuits or material jubs that might touch energized parts, they get tested too.
Okay, so Class A boom is the key insulator, heavily tested. What about Class B then? The gloving trucks.
Very different approach. With Class B, the bucket is typically not meant to be intentionally connected to energized distribution voltage.
Not connected.
Most Class B buckets do have an insulating liner, which gives some extra protection. But, and the source stresses this, a fiberglass bucket by itself offers very little insulation.
Really? Just the bucket itself isn't enough?
It's not nearly enough for primary protection. For safety on Class B trucks, you absolutely must cover all energized parts, all conductors, and even potentially conductive parts of the truck itself with proper insulating covers. Blankets, hoses, that sort of thing.
So the protection comes from covering up the hazards, plus gloves, obviously.
Exactly. Rubber gloves and cover-up are paramount for Class B work.
Now, our source mentioned a common misconception here, especially with newer workers. Something about testing.
Yeah, this is critical. Some people mistakenly think Class B buckets get dielectric testing like Class A booms do. They don't.
No.
Only the booms of Class B trucks are typically tested for insulation, not the buckets. That Class B bucket does not insulate the worker from electrical contact. It's the gloves and the cover-up doing the heavy lifting.
That's a vital distinction. Get that wrong, and
You're in trouble. And related to this, the source flags another unsafe practice. Hanging metal tools or, conductive stuff over the outside edge of the bucket.
oh, like hanging a wrench over the lip?
Exactly. Seems convenient, maybe, but it's caused a lot of incidents. Creates a potential path for current, especially if it contacts something energized, even at primary distribution voltages. Safest bet is keep conductive things inside the bucket.
Makes total sense. Okay,
Yeah.
We've got the regulations, the truck types. Let's talk about the field. What insights does the author share from, actually watching crews work or doing audits?
Well, one really practical point is keeping booms and buckets, both Class A and B, clean and dry.
Why that's so important?
To prevent tracking. That's when electricity finds a path along dirt or moisture on the surface. It can track down the boom to the truck frame.
Creating a hazard on the ground.
Precisely, which links to another point. All non-dielectric trucks, things like digger derricks or regular cranes working near energized lines, they must be grounded according to 1910.269 Phi, and then barricaded off.
Barricaded? Why?
To protect everyone else on the ground from hazardous step and touch potentials, that's dangerous voltage differences that can build up in the ground near the truck. Touching the truck while standing nearby could be fatal.
Right. Step and touch potentials. Got it. So grounding, barricading, and keeping things clean.
And regular cleaning and waxing, like the manufacturer recommends, helps maintain the boom's insulating properties too.
Okay. The source also mentioned something about using Class B buckets in high induction areas, like big substations, and workers feeling discomfort.
Yeah, extra high voltage substations, places like that. High induction means strong electromagnetic fields.
And that causes static or...
Sort of.
Right.
Workers can feel potential differences building up. That discomfort, maybe like your hair standing on end but more intense, is a sign of that electrical potential. It's a hidden danger.
So what do they do about that? The source mentioned alternatives.
It describes two methods, though it says they're rarely used. One is the worker stands on a special ground mat inside the bucket and connects that to the grounded bus structure.
Okay.
The other uses a connected system ground lead running from the basket itself directly to the grounded bus. Both aim to equalize the potential, basically put the worker at the same electrical level as the structure they're near.
Interesting solutions for a tricky problem.
Definitely. And, this really brings up a crucial question based on the source material. What's identified as one of the most common factors contributing to bucket-related incidents?
Let me guess. Something fundamental.
You got it. It often comes down to failing to properly cover all the energized parts and conductors. including potential second points of contact and those potential differences in the work area.
So cover up again.
Yeah.
Keeps coming back to those basics.
It really does. Overlooking those basics is often where things go wrong.
So after all this, what does it all mean for you listening? I mean, this deep dive has really shown the incredible layers of safety involved in bucket truck operations. It goes from these very specific OSHA rules down to the subtle differences between truck types and right into how crews work in the field. It's complex.
It absolutely is. And understanding these details, it's not just for the utility folks or the safety pros. It's really about appreciating the complexity and the sheer dedication that goes into maintaining the power grid that, we all rely on every day.
Yeah, you see those trucks differently once you know what's involved.
Exactly. They're not just trucks, they're complex safety systems. And knowledge like this, it's only valuable when it's understood and actually applied.
So here's something to think about. Considering all these detailed safety requirements we've discussed for bucket trucks near energized lines, how might that same level of rigor, that same attention to the hidden risks, apply in your own daily life, or maybe in your own workplace?
The views, information, and opinions expressed during this podcast are solely those of the individuals involved and do not necessarily represent those of Utility Business Media and its employees. It is strongly recommended that you discuss any actions or policy changes with your company management prior to implementation.